Hello friends, in this new video we prove some identities using a method of separation of symbols is shown on your screen. Ux equal to ux minus 1 plus delta ux minus 2 plus delta square ux minus 3 plus delta raised to n minus 1. Now friend, if we consider these two terms ux minus delta raised to n ux minus n, then we write this as ux minus delta raised to n into e raised to minus x into ux. Now take ux common, 1 minus delta raised to n e raised to minus n into ux, or we write this as 1 minus delta raised to n divided by e raised to n into ux. Again e raised to n minus delta raised to n divided by e raised to n into ux. So this is equal to e raised to n minus delta raised to n divided by 1 into e raised to minus n of ux. Friend, we know that relation between the operator e equal to 1 plus delta. So e minus delta equal to 1. So let us put this value e raised to n minus delta raised to n divided by e minus delta into e raised to minus n into ux. So this is equal to, now taking this e raised to e minus delta as a one factor, then the second factor of this is equal to e minus delta is one factor and second factor is e raised to n minus 1 plus n minus 1 plus e raised to n minus 2 into delta plus e raised to n minus 3 into delta square plus delta raised to n minus 1 into e raised to minus n into ux divided by this denominator e minus delta. So e minus delta get cancel and this will be, this is equal to look at this, this is e raised to n minus 1 and this is e raised to minus n. So e raised to n get cancel and we have e raised to minus 1 plus delta into e raised to minus 2 plus delta square into e raised to minus 3 plus delta raised to n minus 1 into e raised to minus n operating on the symbol ux. So this is ux minus delta raised to n into of u of x minus n. E raised to minus 1 operating on ux, this is ux minus 1 plus delta ux minus 2 plus delta square ux minus 3 plus delta raised to n minus 1 ux minus n. So transfer this term to this side, we get ux equal to ux minus 1 plus delta into ux minus 2 plus delta square ux minus 3 plus delta raised to n minus 1 ux minus n plus delta raised to n ux minus n. So this is our required result. Now we prove one more identity. u0 plus xc1 delta u1 plus xc2 delta square u2 plus delta raised to x into ux equal to ux plus xc1 delta square ux minus 1 plus xc2 delta raised to 4 ux minus 2 plus delta raised to x into u0. Now consider the RHS equal to ux plus xc1 delta square ux minus 1 plus xc2 delta raised to 4 ux minus 2 plus delta raised to x into u0 equal to we write this as this is this will be we write it as here ux plus xc1 into delta square into e inverse ux plus xc2 delta raised to 4 e raised to minus 2 into ux plus delta raised to x into e raised to minus x into ux. So x minus x will be 0. We can take ux common and this will be 1 plus xc2 delta square e raised to minus 1 plus xc2 delta raised to 4 e raised to minus 2 plus delta raised to x into e raised to minus x into ux. So this is nothing but the expansion of 1 plus delta square into delta square into e raised to minus 1 whole raised to x into ux. So if we expand this term, this is as a first term, then xc1 though this is equal to again this is binomial expansion, we can apply binomial expansion. So this is 1 plus delta square divided by e into ux. Now take LCM e plus delta square divided by e ux. Now e equal to 1 plus delta. So delta equal to e minus 1, let us put here e plus e minus 1 whole square divided by e operating on ux equal to e plus e square minus 2e plus 1 divided by e plus 1 operating on ux equal to, so 1 plus e square minus e divided by e operating on ux equal to 1 plus e common e minus 1 divided by e operating on ux equal to 1 plus delta into e. Once again we have substituted e minus 1 equal to delta divided by e. So this is whole raised to x, friend, this is whole raised to x, whole raised to x, everywhere whole raised to x, whole raised to x, whole raised to x, and this is whole raised to x into ux. So 1 plus delta into e whole raised to x into e raised to minus x operating on ux. Now let us take the expansion of this 1 plus xc1 delta into e plus xc2 delta square into e square plus delta raised to x into e raised to x and this is operating on e raised to minus x and x, this will be 0. So u0 plus xc1 delta into e into u0, that is u1, plus xc2 delta square into, this is u2 plus delta raised to x into ux. So we get the required result. So in this manner we can apply the symbols to prove the various identity. Friend, thank you for watching the video till the end.